Alright, so welcome to this video where we are going to focus on the set of numbers and irrational numbers. So in the previous video, I remember we solved one of the question that is actually based on this type of a question whereby they say 0.3 they put a bar. So definitely if they ask you to say what is the same set of numbers comprise of different types of sets. So these same different types of sets, a good example, we can have natural numbers labeled as n, natural numbers, Then we can also have irrational numbers. Irrational numbers that are labeled with letter q. Then we can also have integers that are labeled with letter z. Then we can also have real numbers that are labeled with letter r. So real numbers are all numbers on the number line. So long you have a number on the number line, it is a real number from negative infinity to positive infinity. These all we call them as real numbers. And then integers, we know that these are only positive and negative numbers. Rational numbers, these are numbers that can be expressed in a form of a fraction such as a over b. So this one can just be expressed in a form of a over b. Integers, positive and negative numbers. Real numbers, all the numbers on the number line. This includes even all those numbers that have decimal places, such as even in the fraction like 1 over 10 is also what? A real number. Okay, so specifically we are trying to focus on the rational numbers as well as irrational numbers. That's what we're going to focus on in this same video. So what if someone is to ask, say, what are these rational numbers? Rational numbers are numbers that can be expressed in a form of a over b. So all the numbers that can be expressed in a form of a over b, we call them as rational numbers. So again, rational numbers, they all have, or they can also be termed to as the numbers that are having a repeating number just after the decimal place. And how do you express a number which is having a repeating number just after a decimal place? The same number which is having a repeating number just after a decimal place, we call it a true number. A true number. So these same true numbers, how are they written? We can have 0.3. If you put a bar, this simply means that even the numbers following after this number, they all have 3. Apart from that, we can also have this scenario whereby we have maybe 0.156. So if the bar is just on these two numbers, automatically this implies that the repeating numbers after these are also what? 5, 6. Then you go 5, 6, 5, 6, something like that. Now, these numbers, for you to come up with these numbers, you express them in a form of what? In a form of a over b. So long we express it in a form of a over b, automatically you are saying this is what? A rational number. Okay, so suppose a question has come to say, it has come like the way this one is. If they say, can you express this one in a form of a over b, where a and b are integers and b can't be equal to, b shouldn't be equal to what? 0. This implies that we have to express this same number in a form of what? A over b, where b shouldn't be equal to 0. And how do you express the same numbers in a form of that? For you to express this one in a form of that, you must come up with two different equations. The same two equations must have repeating numbers after the decimal place. What do I mean when I say repeating numbers just after the decimal place? This number, if you see, it can be written as what? 0.333, and then I can put dots to show that these same three numbers, they are also continuously going. So for you to express this one, to express this number in a form of that, automatically you have to come up with two different equations based on this that is having a decimal, a repeating number just after the decimal place. Meaning that this same one, this is a true number. Reason being, it is already having a repeating number just after the decimal point. Now, what am I supposed to do for me to make or to come up with another number that is going to have maybe a decimal point somewhere there, so that I can have 3 as what? By repeating numbers. Okay, so I want to show you in the next page. Okay, so if they say express, suppose a question has come in this case whereby they're saying express 0.3, they put a bar, or sometimes they can just use 3 dot 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 dot. That simply means that the same number 3 is also moving continuously, or it is endlessly, it is repeating itself many times, it is not terminating, something like that. So if they say express this in a form, of a over b, where a and b are integers and b shouldn't be equal to what? 0. So how can you express this one in a form of a over b? Like I said, we have to come up with two different equations that if we subtract the same two equations and then we are going to equate them to the numbers, the same two numbers that are having a decimal, a repeating number just after the decimal point. So already this number, which is 0.3, like this is a true number, reason being it is having a repeating number just after the decimal point. Then you say let x be equal to what? 0.3, you say bar. This one is a true number already. Why? Because it is having a repeating number just after the decimal point. What am I supposed to do for me to come up with another number that is having a decimal, a repeating number just after the decimal point? Remember, this number can also be written as 0.33 bar. That shows that this 3 is also repeating itself. So what am I supposed to do for me to make this number have a repeating number just after the decimal point? The meaning of me having a repeating number, I mean this bar must be closer to the decimal point. Meaning that this entire thing which is here, I have to multiply this by what? By a number which is going to make this point move to the other side, so that I can have a point maybe somewhere there. And what is that number? Automatically, I have to multiply the entire equation by what? By 10. So I'll say 0.3 bar, or maybe I put it like this. I put a bar on the second number. This is going to be what? By the way, this is your first expression. Then the second expression will be 10x equal to, so this point is going to move one step. It will be 3.3 bar, and this becomes the second equation. So this, since it is my second equation, what am I supposed to do for me to come up with such kind of a number, or to express it in a form of that? Meaning that I will say subtract equation 1 from where? From the second equation. So we're going to have 10x equal to 3.3 bar, then minus x, which is equal to what? 0.3 bar. Then I'll say, I'll put minus here. When you subtract this, you're going to have 9x equal to, this can be subtracted, you're going to have 3. You divide throughout by 9, even here by 9. X is going to be what? 1 over 3. We end here, you don't continue from that side. Okay, that is it. Was just a simple introduction based on what? Based on this question. Let me try to solve another question based on the same what? Same type of questions. So the other question, they're saying express 0.13, and then the bar is somewhere there. Bar in a form of a over b, where a and b are integers and b shouldn't be equal to 0. So to express that, if you check this number, which is 0.13, a bar is on 3 and not 2. What am I supposed to do for me to come up with a true number? I have to multiply this by a given number, which is going to move this so that I can have a point just before the decimal place. So what am I supposed to do, or which number am I going to multiply with? I will say, first of all, say let x be equal to 0.13 bar. So the first equation is the one that I am going to get is after I multiply everything by what? By a number that is going to make this point move to the other side. So I have to multiply by 10. I'll say x equal to 0.13, the bar is somewhere there. So we're going to get 10x equal to, then I'll come up with 1.3 bar. The meaning of this bar, it means that you have 0.333, and then my 3 will just keep on going without ending. It will just be repeating itself. So this becomes my first expression. You come to the second expression. What are you supposed to do? I can take it from here. I'll multiply by a given number, which is going to make us have another number that is having a decimal placed just before a repeating number. So what am I supposed to do for me to move this one twice so that I can have 3 bar again somewhere there? Remember, this can also be written as what? As 0.133 bar. So my main aim is to have a repeating number before, a decimal point before the repeating number, sorry. So what are we supposed to do? We can multiply this now by what? By 100, so that the point can move twice. We're going to come that side. I'll have 100, say x equal to 13.3 bar. This becomes my second equation. Now I'll subtract. Now what I'll do, I have to subtract the first equation from the second one. Definitely I'll get 100x equal to 13.3 bar. And here we're going to have 10x equal to 1.3 bar. You subtract. So whenever I subtract these two will go. These two are going to get 12 equal to, here we're going to get 90x. We divide by 90, that side by 90. The x is going to be equal to 3 there can go 3 times, 3 there can go 30 times, if I'm not mistaken. Yes. And then in sorry, this has to be 4, sorry. Then you're going to write our answers like this. You end there, just like that. That's how to solve such kind of question in a case whereby they have given you a repeating number after a given number, which is not a repeating number. Now we try to go to irrational numbers. What are these same irrational numbers? Irrational numbers, automatically, these are numbers that can't be expressed in a form of a over b. So how would you prove if a given number is irrational number? And a good example of irrational numbers, we can have maybe root of 2. I know that this number is not repeating itself even if you are to punch on your calculator. That is irrational number. And how would you check if this one is irrational number? Suppose they say prove that a root of 2 is irrational. So for you to prove that this one is irrational, first of all, you assume that it was what? Irrational. If it is going to give you certain numbers that are common, automatically it won't be what? It won't be irrational. Okay, so what are we supposed to do here? For us to show that this one, or to prove that this is irrational, we assume, but there is a simple method that we normally use for us to prove. What is that method? We say, first of all, you have to write, say, proof by contradiction. This statement is very, very important. It earns some marks. Yeah, based on your lecturers, but automatically you have to write this statement because it helps you earn some marks. So what are you supposed to do next? You say, suppose, you assume, suppose root 2 is rational, not irrational, is rational, and it can be expressed in a form of a over b, where a and b are integers and b shouldn't be equal to 0. Okay, so that is the first statement. Then this statement you write based on what you're from writing. So if this one can be expressed in this format, you say root of 2 has to be equal to what? A over b. Then upper you say square on both sides. So once you square on both sides, how is it going to be? We're going to have this, then we're going to have what? A square b square. So this is going to be 2 equal to a square over b square. Then this can also be written as what? 2b square has to be equal to what? A square. So what statement do you use on this case now? So to continue from here, I know that it has given me something like this. Now what statement are we supposed to write from here? You say if a square is divisible by 2, then a is also divisible by what? By 2. You end there. Then you say let a be equal to 2k. You just let a to be equal to 2k so that we get 2b square equal to 2k square. Here we are going to get 2b square equal to 4k square. You divide throughout by what? By 2. We are going to get b square equal to 2k square. And then here again you write a similar statement, which is the one which is on top somewhere there. You say if b square is divisible by 2, then b is also divisible by what? By 2. Okay, so from these two statements, this becomes my second statement and this one becomes my first statement. So conclusion now, how do you conclude? You say from 1 and 2. By contradiction, it shows that both A and B are having a factor of 2. Hence, we say hence root of 2 is not rational and it is irrational. Simple. That's how we do prove these questions. If they say, can you prove that root of 2, root of 3, something like that, the process is just the same. Now, another question can come in by saying, prove that root of 2 minus 1 is irrational. Prove that root of 2 minus 1 is irrational. How do you prove? The same process we're from doing, you say proof by contradiction. And this statement is very, very important. It gains some marks. So you write now, you say, suppose or assume that root of 2 minus 1 is rational and it can be expressed in a form of a over b. B shouldn't be equal to 0, where a and b are integers. Okay, so I'll write again. I'll say root of 2 minus 1 has to be equal to something like this. Now here we don't square. Whenever you see such kind of a question, you don't square. You can only square if you have different roots, like root of 2, and then here, for instance, they put root of 3. You can square both sides. So here the matter is just to make root of 2 the subject. We're going to come up with a over b, say plus 1, and over 1 b a plus b. This is going to be root of 2 equal to that. So if you check these two numbers, we're saying they are integers. So since the numerator and the denominator, they all have my integers, automatically you say therefore by contradiction it shows that both a and b are integers, hence root of 2 minus 1 is not rational and it is irrational. Hence proven. Thank you.